Have you ever watched a lightning storm and wondered, what exactly causes those bright flashes across the sky? Lightning can be both mesmerizing and terrifying, and it's one of nature's most powerful displays. But what's really happening when we see lightning, and why does it strike in such intense bursts? Today, let's dive into the science of lightning, how it forms, and some incredible facts about this natural phenomenon. To start, let's look at what lightning is. Lightning is essentially a giant spark of electricity in the atmosphere. It happens when there's an imbalance of electrical charges between the clouds and the ground, or even between different parts of a single cloud. Think of it like a giant battery, where positive and negative charges need to balance out. Lightning forms in storm clouds, also known as cumulonimbus clouds. Inside these clouds, there's a lot of turbulence, with strong upward and downward air currents. As these currents move, they cause water droplets, ice crystals, and bits of hail to collide and rub against each other. This constant movement creates friction, which builds up electrical charges in the cloud. Over time, the top of the cloud becomes positively charged, while the bottom gathers a strong negative charge. Now, this buildup of electrical charges creates a huge difference in energy, or voltage, between the bottom of the cloud and the ground, which is typically positively charged. When this energy difference becomes too intense for the atmosphere to hold, the cloud releases it in the form of lightning. It's kind of like a massive release valve, letting all that built-up energy discharge in a flash. But how does lightning actually strike? The process happens in stages. First, a step leader, or a stream of negative charges, comes down from the cloud in a zigzag pattern. This leader doesn't reach the ground right away. It moves in short bursts, like an invisible staircase, getting closer to the ground with each step. When it gets close enough, positive charges from the ground reach up to meet it, and, bam, they connect, creating the bright flash we see as lightning. That connection is called a return stroke, and it's the part of the lightning strike that we actually see. The return stroke travels back up to the cloud almost instantly, releasing a huge amount of energy in the process. This is what creates the flash of light and intense heat, which can reach up to 30,000 Kelvin, about 5 times hotter than the surface of the sun. And that intense heat is also what causes thunder. When lightning superheats the air around it, the air expands rapidly, creating a shockwave that we hear as thunder. Because light travels faster than sound, we usually see the lightning first, then hear the thunder afterward. Did you know that there are different types of lightning? The most common type is cloud-to-ground lightning, which strikes from the cloud to the ground, but we also have cloud-to-cloud lightning, where lightning flashes between clouds. There's even heat lightning, which happens so far away that we can see the flash but don't hear the thunder. And here's a fun fact, lightning doesn't only strike during storms. It can also happen during volcanic eruptions, forest fires, and even intense snowstorms. These types of lightning occur when there's a buildup of static electricity from particles colliding, just like in a thunderstorm. So, what causes lightning? It's a powerful release of electricity that happens when there's an imbalance of charges in the atmosphere. Storm clouds create this imbalance through constant movement and friction, which eventually discharges as lightning. And every time you see lightning flash, remember, it's one of nature's ways of balancing out energy on a massive scale. The next time you see a lightning storm, you'll know there's a lot more going on than meets the eye. If you enjoyed learning about lightning, hit that subscribe button for more science explainers. And let us know in the comments, what other natural phenomena would you like us to break down?